This conference is being recorded.
Okay, we got to record. Got a little bit of echo on me.
All right, I can see you, Harry.
Got an echo too. All right. I wanted to.
Harry, people need to do themselves.
I don't know why we got echo. Okay.
If everyone can mute themselves, there's probably an echo coming from somebody.
Okay. No echo. No echo now. All right. I'm going to start talking here. I advertised this meeting as a debate, and my understanding is that we're kind of not that many people want to present, and so instead of having a prepared presentation, we'll just have a discussion. The topic I picked was did CERN discover the Higgs boson, and the message that was sent out describes what that is about, and that was that David asked me to look at the film Particle Fever, and I thought that was an interesting film, and it was a gold mine of stuff that you could really pick apart in mainstream physics. So I wrote a review of the film, and people can see that at the John Chappell philosophy site, and where I have a page there. So if you read that, then you might know a little bit about some of the things that I discovered in looking at that film. But the main thing I discovered, and I wrote another review of BBC, no, it was a NOVA program. What I discovered was there seems to be different mainstream films give different conclusions about what they discovered. Some people think that discovering the Higgs boson proves this supersymmetry theory, but the Higgs boson didn't appear where it was supposed to, according to the predictions. It was all very confusing. So the take I got on it was it was more confusing than anything. What did they really prove or discover? If they discovered the Higgs boson, it looks like it wasn't consistent with any of the theories that the people were promoting. And the more I looked into it, the more confused I got. So perhaps we can bring some clarity into the picture. So hope we can get this going. I see Bill Lucas is here. And I guess you could raise your flag if you have some comments or would like to talk a little bit about. The main question in my mind is, did CERN discover the Higgs boson? If they did, does that throw mainstream physics into confusion? I don't know. I don't know what the answer is. So that's kind of why we're having this discussion today. So I don't see any flags. Hopefully somebody's going to want to say something. All right, so Franklin wants to say something.
Hey, Harry. So
Yes.
I read over your article, and actually I hadn't heard that the 125 giga electron volts was an inappropriate or non-predicted value for the Higgs, because I thought that they just didn't have any idea where that thing could be, so any value would have been fine. So I think I did see some of the videos that you had mentioned. I don't think they said that, or I saw some other ones, where they've been hunting for the Higgs, and they've been looking for that in the other experiments.
this is exactly the point of confusion that I got out of it, which was the film particle fever. They made a big point out of that the discovery of the Higgs boson would confirm my theory. Now, I was kind of naive in that I didn't really realize that there are a bunch of different theorists. And this film focused on two particular theorists. One had a multiverse theory, and the other one had a kind of supersymmetry theory. And in the film, they sort of did a pre-documentation filming, and they were filmed. One guy was saying, well, I certainly hope that they confirm my theory. And the other guy was saying, oh, I hope they confirm my theory. And in the end, the film kind of confirmed neither of their theories because they found it at 125 giga electron volts, where neither of the quote characters of the film had predicted it to be. And I was kind of very much misled by that. Because I didn't discover until after I'd seen the film and written the review that there was no prediction about where the Higgs should be to begin with. So that was very confusing.
Yeah, I guess, well, I would think that actually the multiverse people and the supersymmetry people are equally insane. So it's not surprising to me that actual experimental results doesn't really match up with what they were thinking would be, since they are pretty much in fantasy land anyways, right?
Well, I have a basic problem with you're looking for a particle where you don't have a prediction to begin with as to what the characteristics of the particle should be.
Yeah, I think that is the main problem. I mean, how can you find something when you don't even know what you're looking for? That's the main problem with whether they actually found the Higgs, because, basically they just scanned the entire energy spectrum from top to bottom. It's like looking for your keys in your house, right? You just look everywhere, right? Until you find something, right? But what did they find? All they found was a
Well,
bump in the data.
they found the Higgs boson apparently. Now, they supposedly and I did a little, I'm not an expert on this, and you go on the internet and you get a lot of confusing stuff. You do a search and you get stuff from 5-10 years ago, and you think that it's, the latest story, and it's not. My understanding is they've started up the Large Hadron Collider, and they're doing preliminary collisions. I guess that's the word they use. And so that's apparently they restarted the LHC. So everybody's waiting for the next run of results that will come out probably this summer. What that, one would wonder what exactly they're expecting to find. What's the latest update? So I don't know if there's anybody here today who is a more up-to-date knowledge of what's going on with CERN and the Higgs and what they're doing. I appreciate knowing about it.
I think it's kind of a big secret because I really haven't heard anything about what they're doing. It's a big startup, but I think they're all kind of hiding because they know that if they actually tell people they haven't found anything, that they'll get their funding cut.
Well,
So I think they've been hiding for the past 2 years, thinking, well, they're so-called rebuilding the LHC. That's a good way to, hide the fact that they really don't have any results. Because it's been 2 years since they did that, and it's like, I haven't heard anything since. There was that big announcement, and then, nothing. I mean, they've been poring over that data for 2 years. I mean, but yes, just yesterday I saw them say something about them seeing the blue mesons in the data, and that was kind of a rehash of what they saw before. So for 2 years, I don't think they've really been doing anything. But Richard just has a basic question that he doesn't understand how the Higgs particle and the Higgs boson actually work. Now, I think I have somewhat of an understanding of what mainstream thinks. So
can anybody hear me?
I just heard somebody.
Yeah, this is Glenn Baxter.
Hey, Glenn.
Yeah, let me address that just very, very, very briefly. think of the universe as being full of snow with individual snowflakes, and think of a skier skiing on top of the snow, going pretty much unobstructed over the snow. That would be a photon, analogous to a photon going through this universe full of snow. Then think of somebody with snowshoes trying to get through the snow. That would be something with mass. And then think of something of going through without snowshoes at all, and that would be something with a lot of mass. So, Franklin, the Higgs field, like the snow throughout the universe, is like to me, it comes across to me as an ether. The Higgs field is an ether made of these tiny particles, like the snowflakes, which are supposedly the Higgs boson.
Well, actually, that's not true.
That's my understanding of what they think the Higgs boson and the Higgs field is.
Well, actually, I believe there's a site on the internet called the Higgs FAQ, and that's hosted by some guy scientist who does that. And so, I asked him pointedly on this. There's a basic misconception that the Higgs field is made out of Higgs particles, or made of Higgs bosons.
Why do you say that's a misconception?
That's absolutely not true.
What? Oh, so I don't know if it's true or not, but why do you say this analogy that I just gave you? If you click around on the thing that Harry sent out, there's some guy with a PhD on there. One of them.
Yeah, the analogy for the Higgs field is correct.
Excuse me?
That the Higgs field is made out of something is correct, but it's not made out of Higgs bosons.
Well, that was my understanding, and what intrigued me was that the snowfield analogy. What intrigues me is that's really just an ether. The Higgs field is really just an ether composed of small particles like the snowflakes, which are in fact the Higgs the bosons. Of course, if you don't believe in bosons in the first place, I mean, actually the photon, which is going through this, the analogy was the guy on skis. The photon is a boson as well. So it gets confusing.
Yes, it gets confusing, but this is my understanding, and that is that the Higgs boson is actually a wave that goes through the Higgs field. So like they're thinking that like the Higgs field is like a medium, like you say, some kind of ether or something, and that it supports waves. Like we have electromagnetic waves, or we have water waves, or we have sound waves. Well, there's supposed to be waves that go through the Higgs field.
Well, how would that be an explanation of what mass is? That the Higgs boson.
Well, the thing is that the people who are looking for the Higgs, the only thing that they truly believe in is this Higgs field, and they actually don't know what the Higgs field is made out of. See, even if they have the Higgs boson, the Higgs boson, like I'm trying to explain, is a wave. It's like they say it's like the smallest wave that can be propagated through that field. Now, waves have energy, right? And through the magic of converting energy to matter, they basically call that theoretical matter particle the Higgs boson. So they're thinking that at high enough energies in their accelerator that they'll actually be able to create one of these waves, and that then that wave will then decay into something we can see, which is typically 2 photons. And so all they're looking for is this energy signature of this wave. And that's why they're scanning all over the place for these 2 photon events that happen to be a little bit more than the background. Because these photon energy events occur at absolutely all energy levels. I mean, you could, if you make a graph, you can see it's a pretty smooth curve on, the energy for any 2 photons flying apart. And
so you're saying that this guy that was on this video that you click around on Harry's thing there and you can find it, PhD, that his analogy saying that the snowfield analogy is wrong.
No, that's correct. That is absolutely correct.
Well, he was saying that
analogy is totally correct.
Okay, so and then the snowfield is composed of individual snowflakes, and each snowflake was a tiny particle that makes a field, and is a boson. But that doesn't jive. That maybe I misunderstood it. That doesn't jive with my idea of a boson, because using the skier over the snow, a photon is considered to be a boson.
Well, I don't know that the skier over the top of the snow has any relevancy for light. I mean, I just don't find that to be a very good analogy. The analogy of slogging through the snow is like a Higgs boson.
You're saying this guy that put out this video, this PhD at some conference that he's wrong. That's what you're saying.
Oh, it could be just like anybody else who puts out a video on YouTube. If I put a video out on YouTube, that don't make me right, does it?
I don't think it was YouTube. I think it was some physics conference.
Well, just the same.
Well, I think
because it is massively confusing.
I don't know what they're talking about.
Say again, Harry.
My take on this is that their explanation isn't very clear.
Well, the problem with the Higgs field being made out of Higgs boson is a Higgs boson doesn't last for like a billionth of a second. So how can you build a Higgs field out of a particle that doesn't last for a billionth of a second?
Yeah, but
that's why Harry says it's confusing. I mean, I think all of us here have at least average intelligence.
Let me give my take on it.
Oh yeah, let me hear Harry's take.
My take on it is that what they're calling the Higgs boson is the quantum mechanical particle. So in quantum mechanics, what they say is they have a particle that's the mediator of the field. Okay. And the Higgs boson is the particle that mediates the field, just as the photon is the particle that mediates the electromagnetic field. And that is my understanding of what they're saying, which is different from what both of you are saying.
Oh, it is. Now, this field, this is just another field. We have magnetic fields and electric fields and gravitational fields, and this is yet another field?
That's my understanding.
All right.
That's my understanding. So that's what and this Higgs field is another field. It's another force of nature, if you will. So you'd have, the traditional physics. You had gravity, electromagnetism, the weak force, and the strong force. And I'm not up to date on all that. And then now there's this thing called the Higgs force. Okay. Now that's my take on it.
Yeah, I think that's closer to the way I understand it, that basically the Higgs boson is like the photon of the electromagnetic field.
That's my understanding.
Yeah, okay. All right.
Guys, first you should clarify what is the boson and what is the fermion. So the boson is a particle which can occupy, they can pile up on top of each other in the same state. That's why, for example, lasers work. So photon is the boson, so we can have lasers. Fermions, they cannot occupy the same state. So don't just throw the boson around just like anything else.
Well, I think I understand that part of it. The point that's come out so far is that different people have different takes on it. And so it's not entirely clear what they're talking about. And these films perhaps are not very helpful in that they're trying to talk down to people and oversimplify it for the layman who doesn't understand theoretical physics. And in doing that, they create a lot of confusion. I
think what's
don't have a
confusing,
clear understanding of what they're talking about.
I think we hit on the key thing is that the boson is like the photon of the electromagnetic wave. So it's not a real like physical particle you can hold in your hand. And what's confusing is that, the big confusion is what is the Higgs field made out of? Now,
Yes.
the Higgs field is not made out of Higgs bosons. That would be like saying the electromagnetic field is made out of photons.
Yeah, right.
So the
I probably misunderstood what he was. He did make that analogy, though, but I'll go back and look at it again. I probably misunderstood what he was driving at. So the question, I guess the question is, we don't know what the Higgs field is made out of, nor do we know what the gravitational field or the electric or magnetic field are made out of. Those are poorly understood. Fields are poorly understood, in my view.
Yes, I mean, I have like my own theories that say exactly what those fields are made out of. I mean, they could be made out of physical particles. I'm always saying that the field is made out of positive electrons. Someone else could say they're made out of little green fairies or whatever. But, it could be something.
Dr. McDowell has a complete theory about what they're made out of as well.
Yeah, they could be made of spiritons or circulons or whatever else you might want to pull out of your hat. And so the Higgs field, I mean, they will freely admit that they do not know what the Higgs field is made out of. I mean, this whole Higgs boson thing is just about detecting a wave that theoretically travels through this field. Yeah. That's all it is.
Yeah, which they convert to energy by the magic of E equals mc squared.
Yeah, but the big misconception is that the Higgs field is made out of Higgs bosons.
Yeah,
because if the Higgs boson, I don't know, actually existed as a particle, and I guess they're kind of presuming that at high enough energies it does, that it decays instantly into 2 photons. And the only thing left to measure is just the energy, which is still completely absurd in my mind. But I think that's what they're trying to do.
Does a Higgs field remind you of an ether? I mean, how is that different from an ether?
Well, for me, it is an ether. I mean, the actual Higgs particle, which is the particle that makes up the field, is my ether particle. I mean, that makes perfect sense. That, just like your snow analogy, if you've got snow in the way, you got to slog through it, right? And so every particle that has to travel through space has to travel past these, particles which are sticky to you. And
so every snowflake,
the harder it is to go through.
The Higgs field is made out of all these snowflakes.
Yeah, possibly. It's made out of particles.
And we don't know what the snowflakes are.
No, that's the analogy.
Franklin, why would it make sense for them to look for the Higgs, the particles making up the field, in addition to the Higgs boson? Why wouldn't they be looking for both of them?
Because they're silly.
Yeah.
Okay. I'd like to hear from Bill Lucas. Bill, I'm unmuting you if you're out there. I guess, are you unmuted? Could you say something?
Yes, I'm unmuted at the present time. Can you hear me?
Bill, as I understand it, you're a particle physicist, right? Or you did, I mean...
Well, theoretical physics, it's a particle physics.
You started out doing work in accelerators. I've never worked in an accelerator. So I'm going to ask you, what's your take?
Well, first of all, there is a division of opinion in the scientific community as to how do you prove a particle exists. And the one
let
opinion.
me stop you here, Bill. That That doesn't come out in any of the mainstream. It didn't come out in Particle Fever, and doesn't come out in any of the documentaries that I looked at on this.
I know. That's because you're seeing only one point of view, the point of view that's currently dominant in terms of money.
Well, that's the criticism that I make of the science documentaries, which are deceptive.
But I think you'll see, the reason why I want to show these two points of view is one point of view will claim that they didn't discover the Higgs boson, and it doesn't exist. It's not a particle. And the other point of view is that it is a particle. So the 2 points of view are, if you have a particle, then you should be, and you can make it in an accelerator, then you should be able to form a beam of these particles and perform experiments with them. Even if they're very short-lived, you still should be able to do that. And we have 96 particles for which we can do that. 96 different elementary particles. But the current list of elementary particles is about 400. And these other particles are required by theories, and so they have not been able to find them experimentally and form them into a beam, even though they're supposedly making them in accelerator experiments. So what they do is they look at what their theory says should be the results if this particle decays or undergoes a reaction, according to their theory. And then on that basis, they justify the existence of the particle. And so one type of particle exists independent of theories, and the other type of particle exists only within that theory. So how many theories of elementary particles, the standard model, do we have? Well, we have quite a large number. And these theories have been, scientists have complained about these theories because the standard model of elementary particles, the simplest one, has 19 adjustable constants, and the more elaborate ones have 29 adjustable constants, where you have to get the constant by fitting data. And you can't predict the constants. Each constant represents unknown physics. And yet they're claiming this is the best theory in science in the history of the world. And but how would you feel if the theory of gravity had 29 adjustable constants? Would you feel like you understood what gravity was? Or would you go to Newton's theory, which has one adjustable constant, big G? And so anyway, this is a debate that's going on in the scientific community. But if you can get the money to do the CERN Hadron Collider, which is a lot of money. In fact, this is one thing I noticed in the movie. It's they started this in 1987. It's almost 30 years old. They just took the first season of data a few years ago, and now they're getting ready to do the second season of data. They've improved the accelerator. They've made it higher energy. They've improved the data collection capability. And I wouldn't be surprised if this time when they discover the Higgs boson, it has a different mass to fit one of the theories, because of what the mass they discovered didn't fit any of the theories.
Bill, if I could stop you here, I want to, you make some interesting points, and one of the things that when you talk about the adjustable parameters, one of the things I thought was very disturbing, and I mentioned in my review, was the kind of abuse of scientific method. And in order, if you're quote following the scientific method, you make a prediction, okay, and then you match your prediction against what you measure. That's not what they're doing. They're they didn't have a prediction for the mass of the Higgs boson, so you know, to me, that's not actually verifying any kind of a theory. In my mind, I mean, you're the standard model is just going out there and looking for stuff. They find a particle, they try to fit it into their scheme, and they use the mass that they measure to go back and make a theory out of what they've discovered. That's not actually the scientific method, as I understand it.
Well, actually, Harry, I hate to tell you this, but your conception of the scientific method, which is the current scientific method under the postmodern philosophy of science, is an inadequate method. It cannot
Well, I
discover
knew
any
that.
truth. And the
I know
reason for that is it has taken the role of logic out of the scientific method. Now, if you had taken geometry in high school or something like that, you would have learned the logical side of the scientific method. It's called the axiomatic method. It was used in Euclidean geometry. And there you have postulates. And from the postulates, you derive a theorem or a theory. And if a postulate is disproved, the theorem or theory is falsified. Doesn't have anything to do with agreement with data at that point. Then later on, people like Isaac Newton and others introduced the empirical scientific part of the scientific method, and then they combine the two. And so now you have two ways of falsifying a theory. You can falsify it by the postulate being false, or you can falsify it by the logic of the derivation being false, or you can falsify it by the theory doesn't predict proper data. So those are the ways you can falsify the theory. But the current scientific method says, well, we want to keep these theories we have, we like them, and we have to get rid of the logical part of the scientific method because we want our standard model uses the point particle idealization for elementary particles. And even though people have won Nobel Prizes for measuring not only the finite size of an elementary particle, but also the internal charge distribution. And we have point particles. They don't have finite size. They don't have internal charge distribution. So we don't want to falsify all of these theories we have. So we'd have to falsify electrodynamics, quantum mechanics, and relativity theory if we acknowledged that the logical method would falsify them because they're based on the point particle idealization. And so we don't have this logical piece anymore, and we don't acknowledge that these theories have been falsified by the experimental data that show that elementary particles like the proton, the neutron, and pions and kaons and stuff like that have both a finite size and an internal charge distribution. And so the real question is there any truth? But notice in the movie, they give the impression, and this is what Harry mentioned in his review, is that their science is dealing with absolute truth. And so whatever they discover is going to tell us about the mysteries of the universe and what's going on. And will tell us about the Big Bang and how the universe came about and all that kind of stuff. But if you were to ask any of the natural philosophers from the times of the ancient Greeks up through the time of Newton, if their method is any good, and they would all say 100%, absolutely not. It's no good. You have thrown out the role of logic, and that's a very important part of the scientific method.
So do you think they found anything at the LHC? I mean, what is your whole opinion about how they go about detecting particles in the accelerators? I think that's like the main question.
Well, see, I worked at accelerators, and at the accelerators where I worked, we didn't consider that you had found an elementary particle if you couldn't form a beam of them and perform experiments with that beam. The Higgs boson, they cannot form a beam of. In fact, of the 400 elementary particles in some of the versions of the standard model, you cannot form a beam of 300 of them. You can't verify their existence by that technique. And so the question is, do they even exist, or are these figments of your imagination or your theory that you're proposing? And so that's the question. And
well, they found a bump in the data.
Stop in here, Bill. According to the quote scientific method that they teach in the schools, I just want to stick with that idea. You're supposed to make you have a theory that's supposed to be logically correct. We agree on that part, right?
No, they don't apply that at all. None of the theories of modern science have been falsified because we've discovered that all elementary particles have finite size and internal charge distribution.
All right, but just let me just say, the theory is supposed to be logically correct. Now we know that the theories of physics don't always meet that criteria.
Yeah, but if you look at a diagram of the scientific method, there's no role for logic at all in that method. In my book, I publish the standard textbook diagram of the scientific method, and then I publish the diagram of the scientific method from previous ages. And you see the difference there's no part for logic.
Well, let's just go with what I'm trying to. You sort of messed me up there. Sorry. But the issue for me is you're supposed to have a theory that is logically correct, that meets your criteria for good logic. You're supposed to have a theory that the math is good and it makes predictions, and then you're supposed to do experiments based on the predictions of that theory. And when the experiments match the predictions, then you declare that the theory is true. That's my understanding of what they promote as the scientific method. Do we agree on that?
No, I don't agree at all. The role of logic in the postmodern philosophy of science, which was inaugurated in the late 1960s, it does not include that role of logic.
So you're saying that they don't really have a mathematically correct theory from which to make predictions?
Well, there's a distinction between mathematics and logic. Logic, some areas of mathematics are logical, and some areas don't have anything to do with logic in some sense. But what I'm saying is that, for instance, I have published papers showing that the theory of relativity has 5 principal assumptions, all of which are based on idealizations which are known to be false by experiment. So now we have experiments that show that the foundational ideas of a theory like, say, relativity theory are false. And I published that paper, and it was a great embarrassment to the scientific community in America, and they immediately used all their power to have me fired from all my jobs and source of employment for saying this and pointing this out, because they don't want it to be known that that's the case. And so we need to look at that and see these false ideas. For instance, one of the false ideas, another one that's involved in all of these theories, is that the universe is homogeneous and isotropic. But now, if you look at our solar system, is it homogeneous and isotropic? No. If you look at our galaxy, is it homogeneous and isotropic? No. If you look at what we can see with our telescopes, are they homogeneous and isotropic? No. But that fits the theory that they want. So the theory won't work
Right.
without that. And so they put that in the theory. And if someone comes along and points out that's not true, well, they don't falsify the theory. That this because it involves false idealizations, which you cannot even do the theory without that idealization.
Okay, Bill, let me just stop you. I'm 100% in your camp. And one of the things I noticed is that and I tried to point this out, and I'm doing it kind of subtly in some of my reviews, but they do science backwards. What they do is they get a result in an experiment, and then that experiment verifies their theory. And so you cannot refute the theory, okay, because they point to the experiment as proof that the theory is right. And so what they've created is a tautology. Do you understand what I'm saying?
Yes, but see, they totally ignore the structure of the theory. The theory is based on some foundational ideas, and you should be able to falsify a theory by showing that its foundations are false, and you should be able to falsify it because of use of bad logic.
Can I ask Bill something? Harry, can I ask Bill something? This is Jerry Hinesha.
Go ahead.
I think, Bill, there is some idealization necessary, some extrapolations. Otherwise, things become so complicated we cannot solve them. For example, we know, at least I think, that the universe is discrete, and but we generate infinitesimals, which is extrapolation of mathematics. Which then it works, and we can do integration, differentiation, and all that. So I think that some extrapolations are valid. We know that it does not describe the reality exactly, but at least helps us to solve some problems.
When I was going to school, I had a view similar to yours, and that was what I was taught. And the idea was that idealizations are simplifications that allow you to do the theory more simply mathematically, so that you can get a result and make some progress. And so that was why they were done. And the idea was, over time, you remove these idealizations as you're able to get an improved theory. And but what we have done is we haven't done that. We've introduced more and more idealizations to the point where we need 29 adjustable constants to describe an elementary particle. And when you start thinking about it, that's a lot of unknown physics and everything that you have had to introduce because of all these idealizations. And I think we're losing our way in science by not recognizing that these idealizations need to be removed, particularly when we're able to show that they're false experimentally.
Well, Bill, let me just interject here. What I find troubling is the point that you just made. So what they have is a theory about the Higgs boson in which they don't predict the mass for the Higgs boson, which means they can just go back and adjust those 29 constants to make the result come out to be true. Okay. They just fudge all the numbers. Now we know what the mass of the Higgs is from an experiment. Then we go back and we fudge all these 29 constants in our standard model to make everything come out right. Is that really valid science? To me, it's not. That's my take on it.
Well, if your theories were developed properly, you could work it forwards or backwards. But if your theories are not developed properly, with the role of logic being involved, then it doesn't make a whole lot of difference which way you go, because all of them are going to be skewed, and they won't be necessarily true. You have to be lucky if you get it.
The assumption of mainstream physics is that all the theories are valid, that everything that they've developed, they've created a pyramid, and there are no flaws in the pyramid, and all they're doing is working at the top of the pyramid. So we say, oh, we've got this particle that we need to find called the Higgs that's at the top of the pyramid. It's on the frontier. They don't have any, they think they resist, I think this is a better term, they resist any questions regarding anything about their conclusions at the bottom of the pyramid. And so they're piling, you know, we've got truth all up to the pyramid till you get to the top where there's this Higgs boson. So they feel entirely justified in this 29 adjustable constants thing. To me, I was just stunned when I realized that they had no prediction for the mass of the Higgs particle. So as far as I'm concerned, you could, there's no proof that it exists because there's no prediction from the starting point that allowed them to find it. So to me, it's just kind of like, oh, well, let's go out and find something, and then when we find it, we'll claim that it's the Higgs particle. There's no criteria for proving anything there.
Right, bingo.
Bill, another thing, you are putting too much weight on logic also. You know, we have two-value logic, yes and no, but we have also different kind of logics, like tri-value logic, yes or no or maybe. So where does the logic come from? Is this human creation, or is it a reflection of nature, or is it a subject of experiment, or what is the logic? Where does it come from?
Well,
You're referring to Boolean logic.
The role of logic, if you were to ask someone who was doing in the days of Euclid or whatever, when they were doing the axiomatic role of logic, he would not admit to these roles of yes, no, or maybe type logic. Those types of logic are the invention of man, but they don't have the rigor of the other original types of logic that formed the foundation for natural philosophy. So we have, and that's because they are based, those roles, those types of logic are based on idealizations themselves. And so you've got to eliminate them in every field, but they have been invented in order to try and support what we're actually doing in science. And so as Harry was pointing out, after we get certain theories and we realize we got problems here, we try to go back and justify what we're doing by inventing another area of logic or something like that. But another area that I put a lot of stock in is Henri Poincaré developed in mathematics and in logic what is called meta theory. And meta theory is the theory of theories, and it gives you a way of analytically analyzing theories and showing the logical inconsistencies in the theory based purely on logic. And so that also shows a lot of problems with the scientific theories that form modern science. And under the postmodern philosophy of science, you're not allowed to use meta theory in physics, in modern physics. You're not allowed to use the logical arguments that Henri Poincaré published in the early 20th century that showed that theories like relativity theory were invalid. And by the way, Poincaré was one of the co-inventors of relativity theory. He published his version a year before Einstein. And as a result of his work in meta theory, neither he nor Einstein received a Nobel Prize for relativity theory. And that says a lot, because we claim that relativity theory is one of the most important theories in modern science, and yet he never received a Nobel Prize for it. Einstein only received a Nobel Prize for the work of his wife, Mileva.
Okay,
photoelectric effect.
Bill, let me ask you, is the logic a human invention, or is it a reflection of reality?
Logic is based on the ability of the mind to reason. And so it's an inherent capability that we have, and we, with our ability to reason, we can prove and disprove things, ideas.
So is it a human invention? No, don't tell me this. Answer a question. Is this the human invention, or is it a reflection of reality?
Is what a human invention?
Logic.
Logic?
Yes.
I would say that logic is based on repetitive proofs that are based on experience. So,
Okay.
so it's intuition plus this repetitive experience.
Yeah. Well, you are wiggling out. So let's go back to something more simple. Is the arithmetic human invention, or is it a reflection of nature? For example, the fact that the nature is countable. We have discrete things. We have 5 fingers, 1, 2, 3. So we invent numbers or names for these things. So the nature is discrete. Therefore, we have arithmetics. How we describe the nature, numbers, that's our way. But that means the arithmetics is a reflection of nature. So inherently, arithmetic is built in a nature. So my question is the logic the same way built in a nature?
It has to do with this repetitive experience that we have that enables us to see these relationships from nature, which are hard to I guess you would say, quantify in some sense, but because many ideas in logic are abstract, and but yeah, it's based on what you might call experiments or in the mind, where you see something always appears to be true over and over and over again, and you don't see the exceptions to it. And so
according to you, it is some sort of reflection of nature. It is not a human invention, all right?
No, it has to do with the brain being able to reason, and so it has two. It has a connection with nature, but it also has to do with this repetitive ability to test and see if it is valid. And but the problem that we have with developing scientific theories today is that we know how to use logic to derive theories from postulates or axioms, and we know how to falsify the theories by showing that the postulates or axioms are false, and we are not using it, but we used it for over 2,000 years in the history of science, and we have no justification for abandoning it except that we want to preserve certain theories which would be falsified.
Okay. I quit.
I guess that's getting a little bit off of the Higgs boson topic. I'm sort of troubled by the tautology or circular reasoning that I believe that science is promoting, which is, and I wrote a review of one of the NOVA programs, and what I noticed when they present science in these documentary programs, I think they're more propaganda than documentaries. They present you with the conclusion, and then they tell you how scientists came to this conclusion, but they never present any dissenting views. And so it seems to you like they've discovered absolute truth because they only present to you the chain of reasoning that they allow you to see. And so what happens is that the empirical evidence kind of becomes the proof that the theory is right. And then when somebody comes along and says, I think this theory is wrong, they say, well, you're wrong because the empirical evidence proves that we're right. And to me, that's kind of illogical and invalid. And I think that's what they've done. I think that's what they're doing with the Higgs boson, which is they eventually what will happen is that our theory about the Higgs is right because we discovered this particle. But the way they discovered the particle had nothing to do with the theory.
Yeah, I think I would agree with this whole tautology thing. I mean, the analogy that I just came up with is that suppose you're losing your socks out of your dryer. And so then the assumption, then your hypothesis is that little green aliens are coming and stealing your socks out of your dryer. Okay, so you're trying to prove that little green aliens are taking socks out of your dryer. So you start by saying, well, if that's happening, then I'll see socks disappear out of my dryer. And they do the experiment and say, lo and behold, there are socks disappearing out of my dryer. Therefore, the little green aliens exist. And so by pretty much presuming the thing that they were trying to prove, which is that there's little green aliens, is true, you can pretty much prove anything, right? But that, the fact that the socks are disappearing is not any kind of proof that there are little green aliens taking your socks. I mean, it's perfectly consistent with that, but
what's happening is politics.
To do that.
Politics and money got mixed into science, and science is now a code word. If say, oh, global warming was scientifically proving, they put a science code word on it, and it means that is true, but it is not what's happening.
Well, that's a good point, Jerry. I think you've hit upon a big problem, and when we see when I look at these science documentaries, particularly Nova and BBC Horizon, I get the impression that it's more about propaganda and
oh my gosh,
than it is about truth or anything to do with what's real in the world.
Yeah, it is propaganda. I was raised on Marxism and Leninism. I was born in Czechoslovakia, and they told me that science, physics is influenced by politics. And that time I was arguing with my lecturer that this cannot be true. Math, and physics cannot be influenced by politics. Then I came over here, man, what do I see? Science is influenced by politics, just unbelievable.
Well, I can't argue with that point. Of course, there are a lot of people who think that this Large Hadron Collider project is, how could they not find the Higgs boson after you've spent $11 billion? Could they not find it? That would be awful for them not to find it if they spent $11 billion looking for it.
Yeah, that's right. Yeah. Well, we'll see what happens. They're gonna restart it next month, so. We'll see.
Okay, I got another issue which this kind of is interesting. Saw the bump that they found, the peak that they found. Apparently, there are two humps to the peak, and some people are saying that there are two masses involved. So they measured two different things. There's not one Higgs boson, but two. Does anybody have any comments on this? I find this kind of interesting.
No, but something that Bill was saying, these are resonances. These are not particles. This is just a quasi-particle, which is just a resonance in the energy spectrum. I don't think that these particles really exist as particles,
Yeah, my prediction is when they turn on the LHC and they go looking for those two bumps again, they'll find that they disappear.
No, there will be three bumps.
That was just an experimental artifact.
There must be three bumps, they're not two, two is just three bumps. This is a three-dimensional space. There must be three bumps, just like three neutrinos three quarks and whatever. And Confucius also says that everything comes in threes, so.
Well, that would certainly be interesting, but you make the one thing you point out there is about the resonance thing. I prefer to think about what they're finding are resonances, and of course resonances are, you got harmonics and all kinds of interactions in resonances, and so as soon as I start thinking about it that way, it becomes less substantial to me. These particles, particles are resonances that kind of, to me, takes away the reality of them as being particles.
Well, there's some structure there, certainly, and which is conducive to resonance. So I expect there's some structure, but definitely these resonances are not the physical particles as protons or electrons, as we know and as we work with and implanted them in the silicon, and all this. So I would make a distinction between these kind of particles and resonances, call them quasi-particles or something like that.
Yes, I would agree. I would agree with what you're saying, and also from the two that I've been aware of in the accelerator community, because I worked in that for a number of years. The one camp doesn't believe in bosons. They believe that bosons do not exist as particles, and so
I agree with that. Basically, that is probably true.
Yeah, and when the photoelectric effect was first found, for instance, for the photon, which is supposed to be a boson, when it was first discovered, it looked like it could be explained in terms of a particle, a boson. But then when they did the photoelectric effect on amorphous metals, the same metal but in amorphous form, which means non-crystalline, they found that the particle properties of light disappeared. And then when we did optical chips for computers, we found we had to actually build into the chip the antenna to receive the wave of light, because there was no photons there. And so engineers would say, no, there's no particle. We know, we build the apparatus that works, and it doesn't work on that basis. And so you got these division of opinions, but
yeah, but on the other hand, all the bosons, like photons, they obey Fermi boson statistics. So we know that, and another thing is they occupy the same energy state. So we can build lasers. So all the bosons can be converted, can be used to build the lasers. So if graviton is boson, we can have a gravitational laser, we can have a Higgs particle laser, and all these bosons can be used to build the lasers. So I would agree that bosons are quasi-particles, not the real particles like protons or fermions.
Oh, got a little noise there. So it sounds to me, Jerry, like what you're saying is that the Higgs boson isn't really a particle; it's a quasi-particle, whatever that means.
Quasi-particle, I would call it, yeah.
And what does that mean to you?
It is a wave which is quantized as quantized energy, which is propagating in some sort of medium, ether or something like that. I don't know what that is, but it is not a particle which exists by itself as proton or electron.
Okay. Bill, I wanted to go back to something that you said. My assumption is you talk about sort of a difference of opinion here. Are there people who have, can I go on the internet and see where this people that have an opposite opinion that you're referring to?
Well, remember, the scientific community is very political in America. So if you express your opinion too loudly, you lose your job.
That's pretty clear. We know that.
Yeah. So I'm telling you the opinion of the experimenters who are doing the experiments, but they don't want to talk very loudly. They just talk among themselves, if you know what I mean, and because they lose their job. And so that's what I'm saying. When I'm the division of opinion, they keep their opinion to themselves officially or professionally because they don't want to lose their job.
Well, you have to be retired or work in different field, and you
That's
don't.
right. That's what I'm doing. I got fired for doing that, and I was naive when I was
Well,
a
you
young.
have to work in the food industry, for example, and do quantum physics.
I worked in the computer field. That was
Well,
a
this
lucrative field, anyway.
is pretty well documented, I think. So what we have is the opinion of people who kind of feel in their heart that maybe the published official establishment opinion isn't quite convincing. I like to use that word, not convincing. So that to me, that's the key point. You can in public sort of give lip service to a theory or the establishment viewpoint, but is it really convincing to them? Behind the scenes, are they going to admit to you personally that they're not really that convinced? That's kind of what you're saying, Bill, right?
Yes, and if you go to countries that don't operate their scientific establishment the same way, for instance, in Russia and also in China, they do not operate quite the same way. So you will see that they entertain better views of science than we do in America, and they may eventually outperform us in science because they are not so political. They do have their problems, like in Russia. When you get a grant to do some scientific research, you have to have done the work already before you get the grant. So you know the conclusion of it, and you know you're going to be successful in what you're proposing.
I thought that was how it worked in the U.S.
Well, in the U.S., officially, about half of the research grants in modern physics do not turn out to be useful, the results that were gotten. And but the proposals sounded like they were going to be really good, but the results didn't match that. And that was because they didn't do the work before they asked for the grant. And but in Russia, they can't. They have the practice. You must always be successful. So you must do on your own dime the first research project, and then ask for money to do it and publish the results that you've gotten. But in America, you try to publish it as good as you can to make it look like you got something out of your work. Like, for instance, this work at CERN, it didn't confirm precisely any of the theories of the Standard Model, but they made it say, well, we did find the boson. We got to adjust our theories a little bit, or something like that. So that was how they did it. And by the way, of the 17 principal investigators at CERN on this project, 15 of the 17 said they didn't think they had found the Higgs boson, and 2 said they thought they did. And those 2 were the ones that realized politically they can't say they didn't find it. They had to have something. So they said that they had something. But as you can see, it didn't work perfectly with any of the theories that they had. It looks like something needs to be changed. So either they're going to get improved data, on this next round, next season of experiments, or they're going to change the theories, so they'll predict what was observed.
Do it backwards. So in a few years, we can look forward to having a NOVA program where at the beginning of the program, they say scientists at CERN have proved the existence of the Higgs boson, and then they'll go back and interview all these scientists who will say, yeah, we predicted it in advance.
Oh.
And
Something
it'll
like
look like they knew exactly what they were doing all along and that they're so darn smart that there's no way they could possibly be wrong in what they've discovered. But all after the fact and in hindsight. It's pretty easy to discover stuff in hindsight, isn't it?
Yeah, yeah. Well, engineers unfortunately can't do that. They have to build the bridge, and if it falls down because they use bad science, well, it's obvious to everybody it fell down.
Well, they had to find that Higgs boson. I got the impression, if you looked at in the movie, they had they're all clapping and cheering and everything, but on the screen it said something like, "We think we discovered the Higgs boson." It didn't say we discovered it. It said it looks like we discovered it, or it was really kind of vague.
Yeah.
Anyway, okay, we got another half hour. I'm not sure if we're done with this discussion or not.
Well, I noticed your talk part, the title is, "Did we discover the Higgs particle?" And certainly at best, they didn't do that. I mean, at best, they're discovering the Higgs boson.
I didn't say that. That was a mistake that was made by somebody else.
Yeah, but I think that's a common mistake. That I think that one of the interesting things we've discovered is that they're not really looking for a particle per se, because that would be like a fermion, like an electron. But the Higgs boson is more like the photon. It's a wave. So in that sense, it's even more etheric, right? I mean, how are you supposed to be looking for a wave in a particle accelerator? I mean, even that on the surface seems absurd.
That doesn't really come out. Interestingly enough, I mean, I would go back and watch that movie Particle Fever, which I think kind of gives a pretty good view of the physicists sort of fumbling along in their way, and that actually didn't come out very clearly to me. One of the this discussion here sort of gave me a better idea of what a Higgs boson is than watching any of these mainstream science documentaries did. They didn't give me a very good idea about what they were talking about.
Someone just put a comment. Sujak said the discovery of the Higgs boson is with a doubt confirmed by the Nobel Prize Award, which means that anything that has received the Nobel Prize must be correct by definition.
Well,
which I think is completely, utterly wrong. In fact, I think when we really figure out how physics works, they're going to be really embarrassed about all of those Nobel Prizes they handed out. They're going to have to take them all back.
Well, no, Gore and Obama got Nobel Prize also for something. So I believe in correctness of Nobel Prizes. Yeah, absolutely.
Okay, Sujak just said it was a joke, right? Okay, yes, it is a joke. Ha ha ha. Okay.
Franklin, the point that bothers me about the way they're doing science is that the concept of time, particularly in special relativity, this is where it came to me, where I really started seeing this very clearly, was in special relativity, and you start reading, please, the noise go away. The idea of time dilation, and they're talking about Herbert Dingle, and Herbert Dingle was declared wrong, although his arguments were pretty conclusive that he his logical arguments were very conclusive. But the conclusion was that what Herbert Dingle said was wrong was because they proved that special relativity was correct experimentally. And so it kind of becomes this argument. They prove it's a self-fulfilling prophecy. Another example is black holes. I did a little, I thought this was kind of interesting. And so I started looking at this topic. Well, according to Stephen Crothers, and it wasn't really him so much as this guy named Leonard Abrams, what they did was they found out that the theory of black holes was based on a mistake. So they went back and they found out that Hilbert kind of made a mistake in this boundary condition. And so it turns out that black holes is based on a math mistake. And so now that you base this whole theory of black holes on what looks like the guy could have made a mistake, okay, now you can't admit that this whole theory of black holes could possibly be wrong because it could be a math mistake behind it. So the fact that they found them becomes proof that the theory is right. Do you see my point?
And we've got so many movies that include black holes. It would be really embarrassing if they didn't really exist.
Well, they have to exist because it would be embarrassing if they didn't. The reason they claimed they found black holes was because they had a theory that predicted them, and so they had to find black holes because that had to prove the theory was right. And so now that they claim that they found black holes and they think they found black holes, then it seems obvious that the theory has to be right, even if it's wrong. It's just, to me, it's just, it's insane.
Black holes don't exist. Nobody saw black hole.
Read my review on supermassive black holes on that film there. What I find really interesting is they claim they found supermassive black holes when people have been talking about supermassive objects at the cores of galaxies since the 1960s. And then suddenly in 2000, these people decided that, well, we discovered black holes, as if, they found something new that nobody ever thought of before. But, that's not really the case. They sort of twist the facts to make what they claim is true. And it's revisionist science, basically. They revise the history to make their conclusion come out to be inevitably true.
Well, it's a cult of personality, because if they say that black holes don't exist, that means they have to admit that Einstein was wrong, and then, that is impossible because his personality, like Stalin, Lenin, Marx, is so high that is always correct, and cannot be disproved, that person cannot be wrong. I mean, that. So therefore the black holes have to exist. Even if they don't, I can show mathematically, logically that they don't exist, but that is impossible to overthrow. It's a religion. It's not a science now.
Can you hear me, guys?
Yeah, we hear you like you eat and chew and make a noise. It's annoying.
Thank you very much. I appreciate your support. Anytime. But anyways, I wasn't the one. I had it on mute. There was somebody else doing that. But one thing I do want to point out, because I've been thinking about this problem, and Harry and I have been talking. We did a podcast. I did a podcast with Harry on what he talked about the social revolution in science. And I was trying to think to myself along this lines too, Harry, what is it? What are we lacking? Because in reality, I think most engineers don't buy all this stuff. I don't think, I think if you would really sit down engineers and 99.99% of the scientists in the world, and the number of physicists and the number of people involved with relativity, astrophysicists, theoretical physicists is astronomically small. It's so small, yet they hold the keys to the kingdom. I'm thinking to what my father would say as electrical engineer. He's sort of like, I've paraphrased him all the time. Wake me up when you have something real. And one of the things I'm thinking about and what we're trying to do, let me give an example what our group doesn't have. I'm interested in this group. So give me the history of the people in this group. Who's there? What have they done? What are some of the new great ideas? You know, we have Bill Lucas here. He's got incredible work. He's got going on. Other people here have really great work. We have nothing to tell the people about who these people are. We don't have a place. We don't even have a story for them. One of the things I'm looking to do is to start to produce something very simple, and that is we don't even have an article that talks about, again, here's Bill Lucas, one of the people who has an incredible body of work. Where is the article about him and what his world looks like? What does the universe look like? And when my father asked that question, paraphrased in my own mind, he says two things. He says, wake me up when you have something real. The problem is that we criticize, and we're very good at criticism. And that is wonderful, because you need that. You can't simply go on and tell people, well, we've got a new vision of the universe with my theory, my equations. I've got all these force equations like Bill has, or my father has a calculations for gravity that's better than the Newton, better than Einstein's. We have Glenn Borkert, who has his world with neomechanics. No one knows about these things. We're not helping ourselves in getting the people out there. So when you say, wake me up when you have something new, we have something new. We've had something new for many, many years. And I think what we're waiting for is the wrong thing. We're waiting for us to come up with this one thing that's going to pop it all open. Or if I'm my own theory, if I'm like Bill Lucas, maybe if I do one more thing. But the truth of the matter is, no one, I was thinking this, here's a real simple question for all of us. Describe to the average person on the street, what does the new universe look like according to people in the CNPS? What does that look like? What exciting things do we see? We don't pass that along. People are motivated by what they see. People are motivated by something that happens. You know, just saying something's wrong is one thing, but we don't have that. That doesn't exist. One of the things we're starting to do is we don't have someone criticizing these films that come out that have all these basic problems in science. We're starting to do that. But one thing I did for the meetup group was to create, and no one here probably looked at it, but on our community website, I've created 3 slideshows for the average person for meetup groups, meaning anybody interested in science. One of them is the history of dissident scientists. And I've got some of you guys here today's faces on that. I don't get any criticism. You know why? No one's reading it. No one's using it. And one of the reasons is we don't have, if you come to our website and say, tell me the story about the CMPS, the history, we don't have it. Oh, tell me about its best scientists. We don't have it. So what do we have? We have a bunch of papers that people can index, and we can't find it. So one of the things I'm thinking, we have to, and what Harry's talking about is a little bit loftier, and the social, what is it, the social revolution in science, which is we're teaching people wrong, but we can't get them interested. We got to get them from here to here, and we can't get them from here to here if we don't have anything to say, here it is. We don't have that. They're not going to find it. They come to our website, look around, they see a couple articles on things, but they don't know it. We should have articles about one section. It's articles about scientists in the CNPS, articles about what those universes to those scientists look like. That will get people's interest. Then they're going to start coming around. I think that's what's needed. We're waiting for an equation in one of our theories to bring the world running to us. And normally what happens is either you have a social change, like when Eddington's blessed Einstein, who was pretty much unknown, and then, or we start presenting a world that's much more interesting, like the Earth has been expanding exponentially for the last 200 million years. It's going on a curve like this. There's a lot of evidence for it. This is interesting. I had a meetup group. That was our most popular meetup group. We had 9 people there who came. only 3 of us were from the CMPS, because we have to get the science that's being done in this group for the last 20 years has to get to the public in a way that is going to get them interested. Abstracts from proceedings isn't going to do that. Now, I'll mute myself so I can eat.
Nobody says anything. I think this is not going to happen, David, because the mainstream is going to resist. It is a huge mass which you cannot sway.
I guess I agree with you 100%.
It is all.
I never said one word about the mainstream. You're never going to change that.
It is the information mass. It is the Einstein Anti-Defamation League, and it is all kind of forces which will stop this from happening. So this
no, you can't stop people in my meetup group in Southern Florida coming together who all talked about expansion tectonics. They weren't sitting there with pressure from the mainstream, from anything. And these people had never, ever heard of the CMPS before. They came up through meetup, which they want to find people with like interest. They sat in my father's home. I gave them a presentation for expansion tectonics. They don't care about the mainstream.
Well, one thing is to make a collection of best paper from NPA or whatever this group and list them and try to push them and publish them. Otherwise, other people.
That's not gonna. I agree with. I understand what you're saying, but when I first got into this in 1992, via my mentor, Dr. Carazani, a physicist from Argentina, I sat and I took out almost every book I could on the history of science and read it. I came across a passage that I've told people about a number of times that was shocking to me, and it really proves what really goes on, that history doesn't see this thing, what the past really was. Here's what it said, paraphrasing. And Newton became the head of the mint and spent the rest of his life defending his theories to his peers. That's Newton.
Yeah.
So what we have to understand is the revolution doesn't come from them. It never has. So us to try to teach a pig to sing is a waste of time and annoys the pig. We're wasting our time. What I'm saying is we write articles that gets the person who likes science interested. When a person picks up the newspaper now, they don't pick up about the Higgs particle, read about it and go, oh, wow, they found it. I'm so happy. Most of them look at this, like my father said, this is a bunch of baloney, throw it to the side and go on to the sports page. What I'm saying is we need to, in my opinion, I'm driving people away. It was 18 people. Sorry, Harry. But what I'm saying, this is Jerry, right? I'm talking with Jerry?
Yes.
Yeah, Jerry. What I'm saying is I don't disagree with you because that's not the audience. We need to get the people who like science involved. And the way I have here, I've already have 2 or 3 people in my own work who are now going to become members of the CMPS because we sit at lunch and talk about this stuff. What's interesting is what we're talking about, but it's not in terms, if you put the best 10 papers up there on our website, we're not going to make a social movement. We have to go.
You have to put the sex and politics behind it, and that will make it go.
But the sexy part of it is to tell what, for instance, what is Bill Lucas, his amazing work. It's incredible work. We need to sit down with him and talk about him.
David, slow down. Okay, I understand your point. Question. Okay, now the thing is, when you go out there on and you look on the internet, you're going to find a lot of mainstream stuff. Okay, and then for instance, just as an example, I was looking about ECE theory, which is Myron Evans, and I went on the internet and I get a thing about ECE theory, and that takes me to some physics site where they say basically he's a crackpot. Okay, the problem is you need to get your message out. Okay, so you've presented your case. The question is how to do it. Okay, how to get the message on the internet. Okay, that's the issue. And it seems to me we need to be making films. Okay, we need to be making videos because that's what people want to see. How are we going to do that?
Well, I have an answer for you on one of those. We already have one example of that. We have an example of someone in our group that has millions of hits on their video. You know who I'm talking about?
Franklin?
Neil Adams. Neil Adams made a what I call an edutainment video. It was actually quite expensive to make because he has a lot of money. And that has a gajillion views on it. And that has been, it continues to go on there and it has influenced people. And what I agree with you completely. There's a whiteboard. I have an example of a whiteboard I did for about 3.5 minutes. If we start making these little edutainment things, there's two ways you do it, Harry. The way it works is you're not going to, producing these things will, there's two ways you can do it. You can produce, let's say we produce 20 of these little edutainment videos. It could be a case that one of them will catch fire. It's what we call become viral. It's hard to say what that is, but it could be. The other way it works, and this is how I've seen forks over knives, and a diet that I've adopted for about 16 months now, that I have no longer, reversed my heart disease. That is a grassroots where the members themselves spend time building those around them. Here's what happens. I sent out a new email like I did a couple days ago about this thing. How many people here have gone to our Facebook page or even have a Facebook page and have liked our own organization? So what we need to do is we have to spend time organizing ourselves. We're out there. We have a Twitter account. We have a Facebook account. We have a YouTube channel account. The problem is our own members aren't even there. When I have a meetup,
David, there is another problem which I would like to point out. The mainstream, like general relativity, is cloaked in a lot of math, which is fairly complicated, and not many people understand it. Now, if you try to disprove it or write something and put some math in your papers, nobody will read it. Nobody will understand it. You will not get out and get the populace to follow it, So it is this kind of thing that the math actually, which you could use to disprove general relativity, which I have done in a couple of my papers, nobody will read. Nobody will understand. Nobody will get behind it because math is too complicated for them. So how are you going to combat this kind of problem?
We're not writing about math. Here's what somebody said about some technology I developed with a friend of mine. We developed a computer language for human language. It's an incredible thing. It has the same problem as the CMPS. It's incredible, but no one's using it. The problem is that you have to go out. You have to get it in a way that catches their attention about what it is. They came to me and said, look, you don't need to keep developing. You don't need more equations. You need to market this. You got to try things. So what do? It's like anything. I agree with Harry. You got to make film. You got to make edutainment. You got to make blogs. You got to write those regularly because we have to make sure our websites every time. I'm sending out a DVD for my film. I got my DVD on a film. You know what's on the inside flyer here? It's got a place where you can help out. You know what you do? You go into and like the Einstein Wine Facebook page. You know how they tell how popular things are today? How many likes? Here's what someone comes up. Hey, Dave, you must be a great organization. Your own members don't even like it. So it has to be a commitment amongst us to take time to do marketing. And I'm not talking about going out with billboards. I'm talking about simple stuff that's there that takes you 2 minutes that no one even in our group is doing. You know how many people have gone out and liked we have it up there. I had 3 little big buttons on the email I sent in MailChimp. I even moved it to MailChimp on the bottom. All you had to do is click on it and say like. How many people here have done that? So what we need to do is we have to make these commitments. Harry has made commitments. He's writing stuff now that is for the layperson. They're great articles. We have to do, how do you say, it's a shotgun approach. You can't just do one. You can't just do Twitter. You can't do just Facebook. You can't just do blogs. We've got movies. We have a movie festival now and it's small, but we have movies. We have Randall Myers. We have people doing lecture series. We have my film. We have another film, a couple other films that were sent to us. Those are we have Neil Adams. We're going to be giving him an award because he's got an edutainment dissident video that's got over 1 million hits. Those are the kinds of things we need to do. So I agree with you plenty. When I made my poster, I had somebody evaluate it. You know what they said to me? For every equation you put on your poster, you're going to lose 10% of your audience. Anyways, I agree with you, Jerry. It's just that we need to spend time here. Will the CNPS, will we take the time to do it? I will tell you this. I'm hell-bent on that because I've been around 20 years. I started this in 1992. I know about the MPA since 1996, and I've been around it since then. I've seen progress made within the group. I've seen now in the last year, great progress to put ourselves in the position to be in a place that's important. But we need everyone's help for that.
David,
Well said, huh?
just on, I'm sorry, go ahead. Who was talking?
This is Pal. I was going to say, well said, David. But my question is the Einstein Wrong film only on the Facebook or video someplace on the internet, or also coming to the theaters as you were once planning?
That's a story in itself, but basically to sum that up, the gatekeepers of film festivals are what I call social intellects. I ran into this in the IDA, in the International Documentary Association. First of all, I send it to the biggest 70 film festivals on the planet, every one of them, from Cannes to Sundance to all of them. Now, I know I made it into the finals to a couple because I actually had transmissions with those people because I was arguing with them. And what happens is that when I was in the IDA, the International Documentary Association, where all the documentarians around the world are part of, I noticed a pattern. Every time I would meet somebody new, I would say, "What's your project?" "Oh, I'm doing it on Bangladesh." And they go, "What's your project?" "Einstein Wrong. That's my documentary." "Oh, Einstein's Wrong?" I said, "Well, a lot of people think so. I've been involved with the group for a while, and that's what the idea here is, to show another side." "Oh, if Einstein was wrong, I'd know about it because I read about science all the time, and I love Einstein. So how could you, one person, find this out? It would be an explosion of the atomic bomb in the world." And then they just look at me like, and just totally ignore me. So at that point, that's what happened. Those are the gatekeepers of film festivals. People who are at film festivals are people who are nerdy, who think they are smart, but maybe not that smart. Maybe their filmmakers couldn't make it in the filmmaking world because they are nerdy. I can say that, I'm a nerd. And then they when they see this title, they go, Einstein's the god of intellectual.
David, they make films for themselves. They don't make films for the public. These people who I saw this film Thursday night where this guy did this film on the real McCoy. The phrase "real McCoy" comes from bootlegging liquor. But anyway, in this film, the guy, it was supposed to be about bootlegging. This guy who was a bootlegger, he was basically smuggling rum from Bahamas into New York City, but with his boat. So it was about to be about his boat and this. But the whole film was all about all this propaganda about how these conservative people imposed this horrible policy of not drinking liquor on our people and how bad these people were who imposed this policy on us. And I kept thinking, why is this guy engaged in propaganda? Documentary films are more about propaganda than they are about actual truth. And that's the problem that you're dealing with. These people expect you to produce a film about solving some social problem that they think needs to be solved, not a social problem that you think needs to be solved.
Yeah, I think, David, the Einstein wrong is a wrong title. You cannot use that, that title. You should discuss. You can explain everything in a movie, but title should be something like nudity and gravity, and then behind that title you can hide and disguise all your things which you say about relativity and gravity, which is wrong by Einstein. But you cannot say Einstein wrong. You cannot use that title to succeed. I mean, this is not going to work.
Well, I disagree with you on that, only because I call it the dead soldier syndrome. The dead soldier syndrome, and I've looked at it that way. Here's the conversations I've had at the IDA. I stopped doing exactly what you said. I didn't tell them my title. And what happens is that, okay, I'm gonna see, but what happens is this. I start talking about what it's about. I say it's about a family, and they go, oh yeah, well, what's happened to the family? Oh, they go on this journey, they meet some of these scientists and they find miracles along the way. Oh, that's pretty interesting, and I tell them about that. When they get into the nitty gritty, well, what's the science? They start finding out what it's about, until you get into conversation without ever mentioning wrong, and that is, well, they're challenging theory, mainstream theory. Oh, like what? Oh, relativity. Oh, so they're saying Einstein's wrong. And so what happens is, if you go to the door, if your film is about challenging mainstream theory, you can put whatever title you want on it. And you go to the door of a parent who's just lost a soldier in war, and you're going to stand there and you're going to tell them in the most kind way you can that their child is now dead. I mean, to put this harshly. What happens? Is it going to be the way you say it, or is it going to be the shock of what they discover? What I have found is in my conversations, when I moved away from talking about what it was, people will question you into the corner to find out what that's about. So let's say you put nudity and gravity. Here's what would happen. You get it out there and says, oh no, they just put that gravity to hide that title to hide that this is all about showing Einstein wrong. And they go, oh, yeah, see this DVD? There. That's what I'm going to do with it. So I don't think it has to do with that, because the general public has no problem with that. The problem is the gatekeepers for film festivals are not the general public.
The gatekeepers basically want you to promote something that they already believe is true.
Absolutely. And they worship Einstein.
And I don't think so, guys. I think if they can make money on it, they will promote it. If it is true or not may not matter. If they can make a lot of money on gravity and nudity, they will push it.
Hey, you know what? Hey, Jerry, I'll try to get some funding, man. Let's do the film. I'm open to anything, the way it goes. But here's another thing. This is just another point to get back to Pal Asija. I don't know if you're still here. I think you are, yeah. One of the things is you have to do another film might like this is this diagram I called Forks and Knives, and they are going from a grassroots, and they have gone quite big. And one of the things you do is you start letting people know you have this, you hand it to a friend, let them see it. Oh, I didn't know about this, and you let them see it, that kind of thing. And yeah, it's a building. It's not something I would want to have done, but it is one of the ways that these things can be built. And that is when people see it. I have had in the last, because I'm making these DVDs and showing this, I've had in the last couple weeks, a lot of people see it and they love the film. I'll have people at work come up to me, and I work in a think tank, and these guys come up to me and say, man, and same with, I love the music, great film. I wasn't expecting this. That's where, if we can get that distributed, that's one thing. Yeah. So, I mean, that would be a wonderful thing. But right now, what we need to do is show a community, because they're going to go to my website and say, you have 113 people who like your Facebook page. We have 150 members of the CNPS. Why aren't they all there doing that? So we still have to start down here. All of us help out, take some real time. I don't want to do like put a gun to people's head just to click on a like button on the screen. But we got to start there. If we
But
can't show the
you have to
world, we can't
realize,
do that.
David, that I don't like to like anything on Facebook anymore because I get so much junk coming in.
Yeah. Well,
But you don't get junk coming
David,
in.
another approach would be to make a movie if Einstein were wrong. See? and so that would be, everything would be in a positive direction, but at the end you would flip it over. So
because people discover it's not the title. People will discover what it's really about, and they'll relabel it. This is a thing. I got a master's in linguistics. There's a thing called the Whorf hypothesis, and that is, does language affect culture? Does culture affect language? You can make it even higher. Does language affect thought, or does thought affect the language itself? There's proof over and over in human language. When we put the word retard at the time when it was introduced for people who were mentally handicapped was a completely neutral word. Special, it was a completely neutral word. We used those words. You know what happens in school if you go up to a kid and say you're special? They'll hit you in the face. It used to be a neutral word. Why? Because you can't disguise the word. The word will not change the realities of what underlies it. If you say nudity and gravity, oh, don't go see it, it's just a ploy to get you there because it's really about Einstein wrong. That's what will happen. So we have to get over this idea that labels are the thing that get people there or to or from. I personally think we not only have to market, but we have to market the great and wonderful vision of the universe that this group is now giving the world. Because people go for those kinds of things, then they're going to come back and say, man, this is a great model. Who did this? Who are these people? Where did this come from? If I had all the answers, believe me, we'd be we'd have 4,000 people on our video conference today.
How many you have now?
Oh, 15 at least.
Man.
How
many people did Jerry? How many people did you invite?
Not me. That was Harry. Me?
What I'm saying is, I have to start.
I had to force myself to come here,
But we do have to spend time marketing. We do. I mean, if this group has a choice, at this point, there's two things that can happen. Either I'm going to continue to do it, whether or not people help me or not. But we need to get more and more people like myself involved in getting the marketing done. The scientists are going to continue the work. My dad isn't going to stop to write an article about even himself because he's got work to do. He's later in life. It's not interesting to him. What we need to do is start forming and taking time, and even all of the scientists at least do a few minimal things. I couldn't get them on email. The MPA started out with typed newsletters and sending them by snail mail. The moment we said we were going to pay to go online, the moment we said we're going to use email, the moment we said we're going to use video conferencing, we're still fighting that. Oh, Fuse sucks. No, Fuse is fine. It's your computer that sucks. We have to go through stages just within our group. The next stage I see we all have to realize is that we've got to market it. The books are out there, but we need to write. We have to translate that into film. We have to translate into edutainment videos. We have to translate this into blogs that the average person is going to read and say, wow, I'd really want to read some of what Bill Lucas has done.
I agree that Bill Lucas in particular, get a website at CNPS, get a web page, and write about some of these things.
It's not always easy, Harry. One of the things, and it's true, and you know that, is that scientists themselves aren't necessarily great at communicating to the general audience about what they're doing. I mean, my father is a good example. I mean, I know much more to the general person. I can talk to them about what my father's doing than he can. So what we have to do is either find people who can do both or start doing it ourselves. Interview Bill Lucas, talk to him about what it is.
There's a lot of that out there, but
it's 12:07.
I agree with you that you have to promote your own theory. You have to promote your own theory. We have to promote what we're doing, and that's marketing.
Yeah.
All right.
Okay.
I guess we got off topic here talking about the Higgs boson. So I guess this is.
But you can blame me, everybody, for putting particle. I'm a little over busy, and I'll change that. That was my fault. So yes, it is not a particle; it's a boson. So.
Okay. Thank everybody. I want to thank everybody and appreciate everybody's participation.
Okay.
All right, guys.